what a fractional exponent means in terms of radical. It's real easy. All we're going to be doing today is converting. We're not going to be doing any kind of calculations, okay? Just want to get you comfortable with converting from fractional exponent to radical form and vice versa. Up until this point, we actually haven't really dealt with fractional exponents. We've done whole number exponents and negatives. Okay, the rule for negative, remember, is you make it positive and you flip it. It's pretty simple. All right, so what about fractions as exponents? Well, we know that it's not a monomial. Not that that's a really big deal, but remember, a monomial can only have whole number exponents. But what if it's fractional? What do? It's real simple. Okay, I'm going to explain this step by step for you guys. Yeah. And after you do it, basically after today, you won't really have to do all these steps. You can do it in your head. First of all, we know what a base is. A base is whatever is under the exponent, right? The base can be a number, it can be a variable, it can be an expression. It's whatever is under the exponent, is the base. So the first step of conversion is actually just to rewrite the base. In other words, whatever the base is going to be in your answer when you're converting it to radical form. All right, the next step, I color-coded that wrong, give me a second. The next step is to take whatever the denominator of the exponent is, because it is a fraction, right? All fractions have a denominator. That becomes what's called the index of the radical. So basically you have a radical, right? Every one of these problems, you're gonna draw the base and then a radical. Okay? The next thing is to take whatever this denominator is and make it the index of the radical. So basically you're putting it on the left of the radical. What that means is the fifth root, okay? If it was a 7, it'd be the 7th root. If it was a 2, there's a special word for that. What is that? You wouldn't say second root, you'd say something else. Square, yes. For a 2, you don't actually have to put anything there. When you have a radical and there's no number there, then you know it's a 2. Because it's probably the most used radical, okay? So the second step is to wedge the denominator to the left of the radical, which is called the index. And the way you read it again is if it's 4, it's 4th root. If it's 5, this means 5th root, and so on. The third step is you're going to take the numerator of the exponent, and it still remains the exponent. You're just going to put it up and to the right of the radical. Okay? So just to review, you're taking the original base, you're rewriting it and putting a radical over it. You're taking the denominator and making it the index of the radical. Then you're taking the numerator and making it the exponent. And there is the fourth step, which we'll do here and there. But basically, if you do end up with a negative exponent, you would want to take the entire expression and flip it and put it on the bottom. And like I said, we'll see that in example 3. Any questions about that first example? It's just conversion today. So once you get the hang of it, like I said, you really won't have to write all these steps out. It's just a guideline. All right, let's try this one together. So first of all, the base is going to be xy, okay? And then we have an exponent of 7/2. It's written a little bit differently. Remember, fraction can be written, doesn't have to be top and bottom, it can be written with a slash. So the first thing I'm going to do is take the base and put it under a radical. See, so for all of these, when you're converting, that's the first thing you do. Whatever the base is, you put under a radical, because we're converting it to radical form. Okay, then we're going to take the denominator and make it the index. So what's the denominator of that fraction? 2. So it's just going to become the index Now, like I said, you don't actually have to put a 2 there. I know it's kind of confusing, but it's implied that square root means second root. I'm just going to put it there just so you guys, kind of know that it's there. I'll simplify it in a second. And then we're going to take the numerator, like we did before, which in this case is 7, make it the exponent. That's it. Now, like I said, for this particular example, if there is a 2 there, you don't have to put it. It's implied that it's square root, so you could just write it that way. So it'd be the square root of xy to the 7th power. If the 7 was, yes, that's correct. If 2 was in the numerator, then you absolutely would write it. Good question. Now, if 1 was there, that's actually a good point. If 1 was there, we know anything to the first power is 1. And so you actually, I'll do a quick example since you mentioned that. Let's say it was x to the 1 over 3. Okay, we put the 3 there like we did before. We wouldn't actually have to put the 1 there because anything to the first is itself. So when that one simplifies, I'll go ahead and put it there, but when you do simplify it, it would just become cube root of x. Okay, so if the numerator is 1, it ultimately will go away. If the denominator is 2, it will ultimately go away. It's just simplification steps. All right, example 3, we are going to flip this one because it's negative. First, we're going to take the base and put it under a radical. Let's see if I can move this over a little bit so we get room to simplify. Okay, so 16 goes under the radical. The 2 is going to become the index. Now again, this time I'm not even going to put anything there, right? Because if it's square root, it's implied, so we can just leave it that way. Now we are going to take the 5. All right, so if there's a negative here, just make the numerator negative. It's easier that way. Okay, so I'm going to put a negative 5 here, like that. So we have square root of 16 to the negative 5. Now step 4 comes into play. We need to make the negative exponent positive and flip it. Okay, so it's going to be put under 1, and we're still going to have the square root, and we're just going to make the 5 positive like this. So the way you would read that is 1 over the square root of 16 to the 5th power. So all that is a review of making negative exponents positive and flipping them. Any questions on that one? Again, there is a 2 there. I know I didn't write it. But when you simplify it, you can leave it out because square root means second root.